Here is where we end our night, at the beach, watching the beginning of a new day. Beautiful, isn't it? And then somebody asks, have you ever wondered why the sky is blue? And somebody adds, and why it becomes so reddish at dawn? So we decide to make a little research, and here's what we find. First, it is important to know that the light behaves like a wave, and that its color depends on the length of these waves. We only see a portion of wavelengths which is known as the visible spectrum. It contains all the colors we can see, and the sum of all of them constitutes the white light. Wavelengths longer than red are called infrared, and those shorter than violet, ultraviolet. Keeping this in mind, there is another fact to consider, the so-called scattering. According to this effect, when light hits an atom, it scatters a specific wavelength. In the case of nitrogen and oxygen atoms, the most common in our atmosphere, the scattering is more intense for the wavelengths corresponding to blue and violet. Our eye is more sensitive to green, which means that it will be more sensitive to blue than to violet. And that's why the sky is blue for us. Now, what happens at dawn? On one hand, the light reaching us has gone through the lower layers of the atmosphere, where there is a greater presence of carbon dioxide and water steam, which produce a more intensive scattering to the wavelengths near the red. On the other hand, as the sun is getting lower compared to our position, it gets increasingly more difficult for shorter wavelengths to reach us. For this reason, the lower is the sun, the more reddish the sky will be. This can be seen especially well during the sunset when the show repeats. So the next time we see a sunrise or a sunset and someone asks, we'll know what to say.